Good morning, this is Mike DeLaCluse with Lesman Instruments. I'm showing 9 o'clock. I'd like to thank all of you for taking time out of your busy schedules to join us for non-contact nuclear level, weighing and mass flow, technology that works where others fail. In this webinar, we will be introduced to radiometric, a fancy way of saying low-level nuclear weighing technologies, how you can use it for very difficult level as well as interface applications, benefits of using non-intrusive nuclear measurement, application success stories, and then we'll have some live Q&A. Becky Olliges has nearly 10 years of experience working with gamma nuclear gauging. She provides measurement calculations and solutions to customers on a daily basis. She's been trained on radiation safety technology. Becky is currently a sales engineer at Ronan Engineering in Florence, Kentucky. The phone lines will be muted. If you have any questions, there is a chat tool, a question tool built into GoToWebinar. Please just type in your question and I'll make sure it gets answered. With that, I'm going to turn it over to Becky.
Thank you, Mike. Good morning, everyone. This is Becky Olliges. I'm going to talk this morning about non-contact nuclear measurement and just give you a general understanding of what we've got. My agenda, my goal is to provide an overview of our gamma measurement technology, so you will see some benefits and feel more comfortable using the technology as a measurement solution. I'm going to do that by giving you a little bit of the theory, some of the product benefits. We'll talk about the different things that the non-nuclear technology can provide measurements for, density, weight, and level, and then we'll give you some examples of where it is used. So first, in order to understand what we are talking about, I wanted to give you just a little bit of the theory behind it. We won't get too technical. We all remember chemistry and how an isotope is a non-stable atom. What we do in the nuclear industry is use one of the isotopes that is unstable and use that energy to penetrate through vessels or tanks or material to be received and use that energy to make our measurement. So the way that anybody in our business is offering the solution, they have a source holder that has that little isotope in it. It collimates, penetrates through the vessel, as you can see here. Then there's a receiver or detector that receives that energy. Then from that, there's a brain or a transmitter that then would give you the output that you want as a customer. A little bit more about nuclear systems. They all operate the same way. As our process increases, the signal reaching the detector will decrease. The detector measures the change in the radian or the number of photons being received, and it sends a proportional signal to the transmitter, converting that signal to a measurement output in the user's specified units, like a 4 to 20 milliamp or heart milliamp, foundation field bus, Profi bus, to name a few. Some basic features and benefits of the products. All of the gauges or systems are non-contact. So they mount externally to vessels, to pipes, conveyors. There's little to no modification needed with the technology, and for the most part they're free of wear and tear maintenance because they have minimal to no moving parts. What we like to say is when other measurement methods fail because of the extreme process, that's when the nuclear technology comes in. So extreme processes include high temperature, toxicity, installations, design, viscosity, abrasion, high pressures, dust, moisture. So the types of measurement that a nuclear or radiometric device can make are a measurement of density, a measurement of weight, or a measurement of level. And as a manufacturer, what we offer and what any nuclear manufacturer offers with density is that's on a pipe typically, giving you specific output. It could also be used in line with a flow meter to provide mass flow output. For a weight measurement, it's being installed on a belt, a screw conveyor, an auger, drag chain to provide the mass flow output through the belt. And for level, obviously that's being installed on a vessel to provide a continuous level or a point level, and they even put them in steel mills providing a mold level. So the density principle is the one I'd like to touch on first. That product is pretty simple to understand. The source is obviously on one side, and here's the detector or receiver on the other side. You're mounting it on a pipe that is vertical, and ideally you want the flow to be a downward flow. So we've got, an upward flow, so we have a full pipe, not much air to it. And the picture here is illustrating the amount of solids that's in the slurry. So the less solids that are here, or the lower the density, the more radiation that's coming through to the detector. And here in the second picture, obviously more particles, which is a higher density, and less radiation is being received. Pretty simple concept. If you want to have mass flow, all we would do is have you mount an inline flow meter like a mag meter or clamp on something right near the density detector. That would give you our flow plus the density together would be combined in the transmitter to provide a mass flow output for you. The second principle I want to talk about is weight measurement. Here is the installation. This is the source. Imagine this frame is around the material on the belt. Here's the detector. And what it's doing is measuring the amount of material running through here. So we've got, and then we combine it with a speed sensor. And so we have density from the material combined with speed, which is going to give a mass flow output. Materials that are good on weight solutions, product needs to be pretty consistent. It's hard for a batch process to measure very well. There also needs to be pretty good profile on the belt. And the third principle is the level principle, and that is much similar to the other systems. Source holder with the isotope emitting the amount of energy to the receiver or detector, and the less process, here's a low process, the less process, the more radiation that's being received by the detector. So as you can see, they're all non-intrusive. So if you've got high pressure, volatility, those all work great. Level, from thinking a little bit further in level, we could also provide a point level measurement, which is illustrated here on the left, or a steel level measurement, which is illustrated here on the right. Same concept. The source is emitting energy through the process to the detector. As the mold level rises, the radiation is less. For a point level, it's simply an alarm. When the radiation beam is covered, you get a switch, whether it's a double throw, double pull relay, whether it's a certain milliamp signal out. So the industries that we see commonly using the products are pretty much every industry that's out there. I've got a few specifics here that seem to migrate to the technology because they have found nothing else is working. So we've got mining and aggregates, power, refining, oil and gas, chemical, metals, pulp, paper, dredging, cement, food and beverage. So I like to tell customers that the biggest hurdle to overcome is the radiation part, the isotope. But as you can see here, I've got potatoes, we've got carrots. The radiation beam is not coming in contact with this material, so the food or the process is not becoming radioactive because it's not touching the isotope. So are there any questions before I wrap up?
I don't have any questions coming through, Becky, so
okay.
you know, if there are some other applications. Yeah, that made it through pretty fast. If there are any other applications that you can think of that we might want to talk about before you know, we give up on any questions coming in, why don't you go ahead and talk about them?
Sure.
We have some belt scale or some scale applications that I know that we've done with these. We have some level applications that we've done with them. And I know you've been out in our territory. Maybe you can talk about some of the local applications that you're aware of
sure,
that we've done.
Absolutely. For the belt scales, in our industry, we're putting them in ethanol plants to measure the whole grain, also to measure the wet goods and the dry goods coming out to help the ethanol plants with a better output inventory. We've got some belt scales in foundries measuring sand that goes into the molds for the castings and the forgings. We have some weight scales installed at I'm trying to think, it's a hybrid company that makes grain, seeds to plant in the ground. So they're measuring that as they're bagging it. We also put weight scales in coal mines and power plants where they're coal-fired power plants. With density gauges, we've got everyone in our industry has quite a few density gauges for in the coal industry on the slurries and in the FGD process because, again, nothing else is working to make that measurement, and it's important to the customers to have that. For level, go ahead, Mike.
One of the questions that's come in is what's the accuracy of the weighing measurement on a conveyor belt scale?
They can range from anywhere from plus or minus 0.5%, and it can get as wide as plus or minus 5%. It all depends on the density and the speed.
So the lower the density, the faster the speed, the less the accuracy? Is that?
That is correct. That is correct.
Yeah.
Now I know everyone in the business is trying to maintain a 1% repeatability or accuracy when we're providing a solution. I know for Ronan we're offering. Oh, go ahead.
One of the next questions that came in is your weighing principle slide shows product being measured on both a belt scale and an auger feeding in product. Would this work for adding spice to a food product?
I would think so. Depends on how the spice is being added. We can definitely offline look at the details, but yes, I mean we have the weight scale on an auger itself, measuring lime, cement powder. So just
how low can this measurement go if you have fairly low ingredient measurements? Is there a rule of thumb? Do you have to see the application? What are your thoughts there?
Most of the time we like to talk about the application.
Okay.
Like to have the specifics. because
Okay.
we've done augers as small as 6 inches. So.
But going smaller than that, what are your thoughts on that?
It would be hard.
Okay.
But as a
You need
salesperson, I don't rule anything out.
You need the sensor to have some distance to pick up the measurement accurately.
That's
Is that
right.
correct?
And
Yeah.
the material,
Okay.
yeah, and then the volume of material.
Right. Okay. Any other applications you can think of that have been kind of odd? That you talked a little bit about dredging, and
Yeah.
what you're really trying to measure is the sand silt, not the water.
That's right. They're pulling the sand out of the pond, and they want to know how much is there. 4 or 5 dredging companies are putting those on there, and as you can see here, it's right here as soon as it's coming out of the water. In the States, Ronan offers a specific product that many dredges like that's not regulated as highly by the regulatory bodies, so the dredges get away with that because they don't have to report or continually make the regulatory reportings measurements that way. So they really like that.
You should talk a little bit about that and why Ronan's technology is different in terms of its sensor, because there are certain licenses that have to be attained in nuclear applications, but in Ronan's case, it's different. Can you expand on that?
Sure. There are, in the United States, there are 2 different types of licenses. One is a general license, which simply means that as an owner, you're reporting to your state or to the federal government that you have this isotope. With our low-level device, the same reporting is needed. However, what we find is with a general license, the state or the government requires a 6-month shutter check, wipe test, and with our product being so low in the radiation that you don't have to go through the shutter check or the wipe test every 6 months. So there's a big advantage there. The specific license is obviously site-specific, and you have a person dedicated to that. And a lot of people with level measurements have specific licenses because there's, several inches of steel insulation that they're penetrating. So examples of level measurements would be like coke drums, fractionators, high-pressure separators, digesters, and paper mills. That's just to name a few.
Yeah, things that are very caustic, very difficult to measure with any other contact or even non-contact technology that might be looking in from the top.
That is.
Any cautions in general for using these with a screw auger?
No, none that I can think of. No cautions. I mean, your screw auger, you have a speed. If you don't have a speed sensor on it, we could get a speed sensor on the end of it, as long as we know what the speed is and what you've got running in there.
And you said that there is a size that you like to see the auger be. So you don't want really small augers. You want an auger that is a little bit bigger. Is that right?
That is correct. I mean, I don't know enough to know augers that are 2 or 3 inches, how common those are.
Okay. So the bottom line is we need to review the application, but in general, screw augers work fairly well.
That is correct. That is correct.
Okay.
And actually, the only precaution there is as long as the thing's not totally full.
Okay. Interesting. Next question is, how does this work with a conveyor that might handle multiple types of products?
what Ronan, well, the technology is material, the density, you're taking into account the density and then the speed. So we always say a ton of feathers weighs the same as a ton of bricks. It's just the volume that it's taking up. In our transmitter, we can set several different density settings, and it would be a button to push or something to trigger from the DCS to say you're running a different process. However, the scale itself does a real good job of measuring density and speed because it's measuring it over time. It's not an instant split-second response. It's measuring, 15 to 20 minutes of it. So it does a good job adjusting as the product density changes.
Okay. We are running out of questions. So if anybody does have a question out there that they'd like answered, please send it in as we're wrapping up. We'll make sure that we get it answered. At this point, if Becky, I just want to thank you very much for the presentation. If anybody does have any specific application questions, feel free to give us a call at 800-9-LESMAN. If you do not know your account manager, feel free to ask for me, Mike DeLaCluse, and I'll make sure that you get taken care of. You can also reach me. My email address is miked@lesman.com. If you want to know more about the technologies we supply, please follow us on our website. Dan's blog you can sign up for. It's very active and it has tons of great tips. All of our webinars are posted both on our website under the Learning Center and on our YouTube channel, which is Lesman Instrument Co. If there's something that you'd like to know about of one of our technologies that you're not sure of, please send me an email with your thoughts on what subjects you'd like covered in future webinars. At this point, I don't have any further questions, so I think we'll go ahead and conclude the webinar. Becky, again, thank you very much.
Thanks, Mike. Thank you, everyone, for attending. Goodbye.
All right.